systems of equations, and what we're doing is we're going to solve by graphing. So systems of equations are essentially two linear equations, and we're going to graph, and then we graph each one and we look to see what happens. Do the lines intersect at a point? Are the lines parallel? Or are the lines going to be the same line? So those are your three choices. If we're going to graph, we need to solve each equation for y. That's the first step. So we'll start with the first equation. In order to solve for y, we subtract x from both sides. Would look like this. And so we get y is equal to, I like to write the x first. Okay, so that's our first equation. Same idea, but I'm going to take now the second equation, solve for y. In order to solve, divide by 5. Make sure you divide every part by 5, which gives us y equals 2/5 x, plus we should reduce 1. And so that's done. In this case, what happens is, for the first equation, our y-intercept is going to be 0, 8, and our slope is -1. For the second equation, the y-intercept is 1, and the slope is going to be 2/5. So what we do is let's graph, and when you're graphing your equations, since we need to figure out the exact point that they intersect, you probably need to pick a good amount of points, maybe like 5 points, maybe 6 points. It just depends on the problem. We're going to make the first equation red, and the second one is going to be green. So for the first equation, we start with 8, 0, 8. That's our y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. So that's right here. Then it says the slope is -1, which tells us to go down 1 to the right 1. And I'm going to pick a good amount of points here. So to get more points, just follow the slope. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Okay, so I think I have a good amount of points. I'm going to connect these points in a second. Let's look at the second graph. We'll make that green. Y-intercept is 1, so that would be right here. 0, 1. Then our slope, 2, 5, which tells us to go up 2, 1, 2, and to the right 5. 1, 2, 3, 4, 5. So look, we see that they intersect right here at this point. So the ordered pair at this point is going to be 5, 3, and that would be our solution. Our answer is where the two lines intersect. Let's graph this. Let's just connect the points. Put arrows at the end of your graph. Same thing for the other line. Arrows. Okay, so the answer is the ordered pair where they intersect. 5, 3. How do we check to make sure that this is the correct solution? All you do is you take your answer and substitute it into both equations, either the two that are solved for y or the original two, and make sure it works for both of them. Let me quickly show you. I'll start with this one. We'll just use the one that's solved for y. So instead of y, we substitute 5. And we want to make sure question mark, that that's equal to -3 plus 8. 5 is actually equal to 5. So the solution works for the first equation. Same idea for the second equation. So it works for equation 1. Let's check equation 2. We replace y with 3. See if that is equal to 2 over 5 times 5 plus 1. Well, I know that I can write 5 over 1. I know that I can reduce here. And so we just get 2 plus 1, and 3 is equal to 3, so I know it works. We can always check our solutions, because when you graph, if you don't pick enough points, you might end up guessing where the lines intersect, and we don't really want to guess. That's why you want to make sure you pick enough points so that you actually find where they intersect exactly. Graphing is not the best way to find our solution, so there are 2 other methods that we're going to learn in the next sections.